Hello and welcome to the first video of my channel. Um, I wanted to take this first video as kind of a documentation library of some independent research I've been doing around DICOM devices. DICOM devices are devices used in the medical field operations for like medical imaging, medicine distribution, those types of things. And so just kind of getting into it here so I don't take up all your day. I want to start off with just talking about the DICOM messaging service elements. That's also known as DIMSI. And that's kind of what these command structures are. So you have cecho, cmove, cfind, cget, and cstore. Cecho is kind of like the ping of networking. It's a way to detect whether or not it's alive and you've got all the correct information in your cecho message to be able to communicate with the other side. And one thing I want to talk about here, though, is cecho, or I'm sorry, not cecho, but DICOM itself has a direct integration with another medical protocol called PACS. And PACS is more specific to medical imaging. And so when you talk about cecho here, we also have to talk about PX echo if you want to talk to MRIs and X-ray machines, especially if they're more legacy, using some of the more legacy software, because those are more than likely going to be PACS, even though a lot of things are moving to more DICOM type messaging now. So talking about the cecho command structure, you have what's called the local application entity title, or AET. The application entity title is a way of identifying who you are as the owner of the data. It could be something like radiology department, it could be infusion center, it could be a number of things. And then you need the remote IP address, port number, who are you sending it to, the remote application entity title, and then of course the log level. There is a default log level within cecho, but that can be adjusted according to how you and the organization need it to be done. And one thing to note here is that the local AET and remote AET, when speaking on native DICOM or DIMSI commands, that is pretty much the only real authentication mechanism you have besides IP address and port number. And that's kind of scary, that there's no username, password, or something else, and that's all that you really have to go on. So in my research, one of the things I wanted to try to figure out is, since there is no phone book, theoretically, of application entity titles, what can I do to be able to find and discover DICOM devices and native DICOM devices on the internet or inside of an internal network or anywhere for that matter, and validate that it is actually what it is without knowing the application entity title. And so that's kind of where I am with DICOM-Scanner right now, is more of a, can I discover you? Can I talk to you on your level? And I have actually tested this with PACS devices as well, even though PACS has a different messaging structure with PX, what's called PX echo. PX echo does require more fields in the message of PX echo, but there's still not really a username and password. It's still kind of all based around the application entity title, which still exists in PX echo. So just kind of getting into it, I also did some research on the native ports for DICOM and PACS. DICOM uses 104, which is the privilege port and requires it being an admin. 2761. I've read some other research and watched some other research vlogs around DICOM, and I've heard a few mention that the TLS layer doesn't exist. The TLS layer does actually exist. I do not have it configured in my victim. But I think one of the reasons why it's not used very much, and I haven't seen it used very much, is because the native protocol has some layers of encapsulation already in it that will kind of protect itself from port scanners like Nmap and Unicorn Scan and Angry IP Scanner and all those guys. And because of that, and the message you get back from them, it kind of throws them off a bit. They're not really sure what to do with it. So I think that may be one reason why TLS is not used a lot in the native DICOM area, although I think it should be. And then we'll get to some other things about it in just a minute. But and then with PACS, you've got 1104 and 6104. And one of the other things I've been noticing when researching actually some of the vendors for DICOM and PACS is a lot of them, at least with the DICOM, are not using the standard DICOM ports as listed in the RFC and in IANA. Like Orthonc, for example, the default ports are 8042 and 4242. And something to mention about 8042 is that it's a web wrapper port. So it's actually wrapping itself around the DICOM protocol in order to help protect it a little bit more. It requires a username and password, and you can set up TLS through SSL. Or I prefer not SSL, like TLS 1.2 at least, with a 256 AES certificate, preferably. Um, but um, but it's kind of nice because the web wrapper, especially with the API, it does not allow for cecho. So you have to actually send it a cmove or a px because Orthonc does actually support DICOM and PACS. It requires some other DMC or PACS command other than cecho or pxecho in order to talk to it. But we will run DICOM scanner against it and see what kind of message we get out of it a little bit later. But here's some other vendors that I've been able to identify that actually, and some of the ports that they use by default. And so we'll just kind of get into the next piece here, which is the DICOM toolkit. The DICOM toolkit is actually where I found some of the gold. A lot of the other researchers that I've looked over unfortunately, after I read through all this code, and started trying to pick out ways to be able to talk to the application entity title or identify an application entity title without knowing what the AET was. I don't know if that research came out before or after I started reading through the DICOM toolkit and the Orthonc code, but and the PyNet DICOM code. But one of the commonalities between their research and my research is looking through PyNet DICOM. I actually use PyNet DICOM for DICOM-Scanner, and will continue to use it as I'm doing more and more things against the DICOM in my research. But one of the things I want to mention is, remember with cecho, we talked about having the needing to know the application entity title. And one of the great things about that is that this code here is the Echo SEP conformance code out of the DICOM toolkit. So this is the verification SOP class, and this number is a subclass called SCU SOP class. And so by using this number with cecho, we can actually bypass having knowledge of the application entity title because there is not actually a phone book with application entity titles in it. But if you look through the DICOM toolkit, it kind of gives you one. And considering the application entity title with native DICOM-Scan is kind of a big thing since there's no username and password, what I've been able to identify, at least with cecho, is I can use these commands, or these OIDs rather, instead of using an application entity title name, and be able to talk to DICOM from my client, which is very interesting. The other thing I like about the DICOM toolkit that I did not see in PyNet DICOM is you actually get the new draft OIDs and the OIDs that are expiring. So it eliminates the ability to, or it helps to eliminate the ability to put in legacy things that are no longer going to exist. Although, considering how often tech is refreshed in a lot of hospitals, some of the legacy things will probably still exist, where the drafts will take a while to actually be adopted. So we always have to take that in mind when we're looking at security things, is how long does it take an organization to adopt new technologies, new OIDs, and so that will play a big impact on how long these things will exist. So one of the first things we'll do here is we'll actually open PyNet DICOM. We'll actually open DICOM-Scanner. And remember earlier we talked about the SU SOP class with this OID. And notice that these two numbers match. One cool thing to mention here is I could have actually taken this entire SU SOP class number out and replaced it with just the words verification SOP class, and I would get the same result. But because I want to actually take this a little bit further and go into seeing what I can do with cfind, can I get a list of patient names that are in it? Can I store stuff in it? Does it have to, the things that I store, does it have to be in a DICOM or PACS format? Can I put malicious code up in the, can I put malicious code up there? Those types of things. So that we'll find out a little bit later as I research a little bit further in. But for now, let's actually do an nmap against a DICOM scanner native port and see what we come up with. And what we should come up with is TCP wrapped, and that's because the encapsulation, nmap, unicorn scan, those things don't know what to do with a C echo command and the response that comes back from it. However, if you do the exact same scan on the web wrapper, we will get something, even though it's taking a long time to run. We get a Mongoose HTTP server. And something I wanted to mention is when we ran the nmap against the DICOM server, we got a response message over here on the server side that says receiving association failed, unrecognized PDU type 4A. And that is just another example and evidence that nmap port scanners just don't know how to talk to DICOM. So in order to be able to talk to DICOM, we need to speak to it natively. So we'll just take a look at what the options are here. We can do IP addresses or net range. We actually know what our target is in this case, and so we will do port 4242. And you see we get a success message. No application entity title names, none of that stuff. We just use the verification SOP class ID, and we got that information. So what happens if we use this against the web wrapper port? So notice we get an unrecognized PDU type again. And this unrecognized PDU type looks very similar to the one that we get on the other side from when we did the nmap of the native port. The reason for that is because the web wrapper does not accept C echo commands. You have to send it CStore something else. And I believe the APIs even require a username and password, and that's because it's better protected. So while this could be a false or positive way, I'm still trying to figure that out on whether or not scanning the web wrapper is a way of detecting whether or not it's a DICOM device, but I think it is. So what you get when you actually use PACS. So PACS has actually what's called a serial UID. The serial UID is a slightly different number. I don't actually have it here with me. But you see these are 1.2 to 840, and I believe that the serial UIDs for PACS numbers are 1.5 or something like that. And they're much longer as well. And so that's one of the things, this is something I just recently uncovered. So the next video I push up will not only talk about what I was able to discover with cfind, but also I'll also talk about what I found out about the serial UIDs for PACS and where to identify those. Because I think that would be interesting to add into the DICOM scanner. And just one other thing is that I want to mention is I do actually have a Python 3 version of DICOM scanner. I don't think it's actually up in my repo yet, but it will be up soon. And you'll see the message that comes out of that. It comes out just as fast, but you get a different type of success status message that comes from there. So that's important to know, that we can talk to it on both Python and Python 3. And I have them both set up. And like I said, I just need to put the I just need to add the requirements txt for Python 3 and push this code up, and it will be ready to go. And also, if anybody would like the victim, the orthogonal victim that I have, just leave an issue in my GitHub repo, and I'll be happy to push it up. And just real quick, wanted to show you, here is the web wrapper port, and here's the native DICOM port. So the last thing I want to show you, bring up Ghost Browser here. This is the orthogonal web interface. Notice here it's got hooks for clear canvas, and you'll find some others like DICOM software like Ensemble that hooks into clear canvas, and some other ones like that. I believe there's some YouTube videos. Around Ensemble and somebody doing some cool stuff with that. A guy that wrote a tool called DICOM Buddy did some interesting things. So if you want to look that up, that'd be interesting. That'd be pretty cool to look at. I haven't actually installed all of the plugins for this yet, but I plan on doing so at some point in order so that I can continue my research a little bit more. But here's where I can upload stuff and drag and drop DICOM files. And also just kind of wanted to take you to my repo. I'll also list it below. But this is where I currently have the DICOM scanner sitting in. I'll also release the DICOM 3 stuff, or the Python 3 DICOM stuff here shortly. And like I said, I'm always looking for ideas, examples. If someone else has done some research in this field and would like to help me, I'm always looking for help, especially since I'm doing this independently and don't quite get as much time as I'd like to. That's all I've got for today, but please stay tuned for additional research. If there's other videos you guys would like to hear about, like how is my lab built, or what other kinds of scanners, maybe some SMB research that I did during the WannaCry phase and the scanner that I've written for it, that type of stuff, please let me know in the comments, and hope you enjoyed, and we'll see you soon.